This is homework 12. So in homework 12, lesson 14, problem 2, evaluate the limit of this right here. Right? And what I did was I went backwards and factored out this into that. Cancel these two. And it'd just be minus 2 over 1. And then you put that the limit to 3. That would be 6 minus 2 would be 4. And this is the limit of that. This is a hospital. Evaluate the limit from this, and you can see that it's this form from the L hospital. So what I did is find a derivative, but this derivative ends up being this form again, and I did the derivative again, and it's this again. So until I kept finding derivative until I got a constant number, and you know that anything over a constant number is gonna be infinity. So for number 6, this is this form of interdeterminate way, I guess you would say. So this is the equation x times sine of 1 over x. This I try to find the what I do when it comes to these is I make sure one is in the top and one is in the bottom. That's what I did here. Then I found the derivative of both sides. Gives me this right here. Let me fix that real quick. Once I found the derivative of this, I did keep change flip, so it'd be this. Canceled a bunch of things out, and it ended up being cosine 1 over x. 1 over anything infinity is 0, and the cosine of 0 is 1. Number 8. This is the interdeterminate form of the L'Hopital rule. I did the limit of 1 plus x to the power of 1 over x. What I did here is I did it's called the natural log differentiation thing. I don't remember precisely what it is. But you basically take the natural log of both sides, and then you find the limit of as x approaches to 0. And then you would get e. Well, you would get 1. But it's just a reminder that this is the limit to e. This one, it asks us whether it converges or it diverges. So I did that right here. I changed that into that. Then I found the derivative. So from the derivative, I plugged in the numbers, and it gave me infinity. So it diverges. For number 4, is 0 approaching from negative infinity to 0. 1 over 1 plus x squared. Find the integral. See if it converges or diverges. So I changed this to b, so it'd be like this. Once I did that, I made it approach to b when I found the limit, and then this is basically arctangent. Plugged it in, plugged it in, 0 gave me 0, and then this gave me this. Then I plugged back in the number, and it gave me 1. It gave me pi over 2, and it diverges. Number 6, right here. It converges or diverges. I found the integral, which is this, and then I plugged it in, and it approaches to infinity. Same thing for number 15. well, no, it's different because the integral is undefined at 0. So I have to separate into two different, and they both diverge. Here you write the first 5 terms of the sequence. That's pretty easy. You just do A1, A1, A2, A3, A4, A5. That's what I did here. Then I found the limit of the sequence for number 4. This is the sequence, and what I did is put the limit towards infinity, and I took this from both sides, got this. This approaches to 0. Well, no, technically to 1, negative 1, and then it's over 8, and that gives us the limit of negative 8. Number 16, number 6. Find the limit of sequence for this. I listed all the sequence. And etc., etc. There's a pattern, so it diverges. Find the limit of sequence with this. I put the limit approaching to 0, and what I use is this as a reference, that this limit approaches to e, so by looking at this, we can assume that it approaches to e to the power of 3. We list the first 5 terms of the sequence of partial sums for the series. So I did just that. I did S1, the sum of the first one, the sum of the second one, the sum of the third one, the sum of the fourth one, the sum of the fifth one. And you can see that there is a pattern here. Determine the divergence or convergence of the series. So I used the ratio here. This is greater than that, so it diverges. Determine the convergence or divergence of the series. You can see this is the series, so what I did is plug everything in here, and then I found that it converges. Let me fix that real quick. Then I have to find the sum of the convergent series. What I did is found the geometric series 1/3, so it converges. And then I did this here, and it converges. Okay. So then I got this as the convergent because this is the ratio, or the radius, or the ratio. Then I plug this in here, and then you can see that I got 9/4, but it converges. To verify the series that it diverges, shown right here, that it approaches to 1/2, so it diverges. Then I have to find the sum of the convergent series right here. So what I did is I separated them by using partial sums, and I got this, and I ended up with negative 20/3. The sum of convergent series of 1 plus 0.1 plus 0.001, or 0.1 and plus 0.001. The geometric series given, we try to find the geometric series. So you see there's a pattern here. You can tell that this is the pattern. Then I change it to this, and it gave us 1/10. So that's the sum. So this diverges or converges. What I did is I try to find the pattern, and it diverges because the k term does not approach to 0. Use the integral test to see if it converges or diverges. Here, found the integral test. See that the series converges. Integral test here to determine if the series converges or diverges. This is the series. And this is what I did here. And this one as well. If the series converges or diverges, you can see that they both diverge because they approach to infinity. And 0 is undefined. Now then you use the fourth degree here. So what I did is I found the derivatives of all 5. Got this. It's bounded by 1, and I plugged it in this equation, and this is the larger error than the exact error. Find the radius of convergence here, so I did the ratio test. I did this, keep, change, flip. Radius of convergence is up to infinity because of this. Then find the interval of convergence. I used the ratio is greater than 1, plugged it in. You can see the against for -7. And this one is find the interval of convergence here. So I did the ratio test, flipped it over, got this, then figured out if this is included or not included. So you can tell that -5 is not included because it diverges, and 13 is included, so it has a closed bracket. Thank you.